everybody. My name's Greg Luhman. I'm a business development manager here at Adtran. Thanks for joining me today, checking out the content. Today we want to talk about what's driving the need for 10G PON networks. We're going to talk about some of those motivational pieces that are driving service providers to look at different technologies, advancing the networks, going beyond 2.5G PON. We're also going to look at, some of those solutions that will help in that migration from 2.5G PON to 10G PON, from GPON to XGSPON. We'll also look at a couple other areas of the network that are being impacted when you add 10G services, when you start adding this capability and beefing up your PON networks. What are some of the other things you have to be conscious of when you're delivering these faster services? So we've definitely seen rising traffic growth over the years, but today we're starting to kind of reach that inflection point where we're getting to the very, very vertical part of the hockey stick. So the numbers we're looking at Adtran, things like 30 times more usage over the next 10 years. We're starting to get to that point where we're significantly ramping, and there's a few trends that are dominating this behavior. Things like 4K TVs. 2 out of every 3 global households is going to have a 4K TV this year. And really the prices on 4K TVs have just slid. So we should see those numbers increasing. By 2021, I'll probably be telling you that every household has 2 4K TVs. So we're starting to see 4K resolution really become the soup du jour, if you will. And this, of course, drives our streaming rates as folks are streaming the latest, greatest movies, or I guess in 2020, you probably watched some more classics. But those are coming down in 4K, consuming more bandwidth. Another big development that we had in 2020 that's really starting to launch and is launching in a significant way is cloud gaming. We've seen Google, Microsoft, and now even Amazon, companies like NVIDIA with their GeForce Now. There are a lot of game streaming options out there. So these are turning gaming into Netflix, really making it super convenient for the consumer to just jump on, hit an app on a console or a smart TV or a smart device and start gaming. And today, this isn't just simple casual type games like Tetris. These are AAA fully blown high development dollar games that are coming into the home, and consumers are subscribing to these services, on a monthly basis. So they're expecting that high quality. The goal of the cloud gaming services is to make the quality as if the console is in your home, when in reality, the console is now in the cloud. So we're no longer just sharing small bits of data when we play games with the cloud. We're sharing the entire game and the entire console. So that is a much more bandwidth intensive service. We're talking 35 to 50 megs at the highest qualities, which is what gamers want, of course, for a single session. And gaming is social. It's very typical to find multiple people in a single home gaming. As cloud gaming becomes more adopted by the consumers, we're going to see multiple game streams needing to happen inside a residence. So just a minimum of 100, 120 megs to deliver multiplayer game streaming in a home. We're seeing these ramp up. We'll see them improve. 2021, we'll probably see significant growth here. The other things that are continuously driving, and they've been with us for a couple of years now, smart home applications, connected homes, call it IoT, the Internet of Things, cameras, smart light switches, smart light bulbs. The proliferation of these devices is readily evident if you look at the devices that are deployed in your consumer household. The average household has 72 light bulbs in it, and the goal of these IoT companies is to replace every last one of them with a new smart light bulb or smart light switch that can be controlled from an app through the internet. That's a lot of devices. Well, individually, each light bulb doesn't use a whole lot of bandwidth, but when you look at adding 30 or 40 devices in a home that are communicating all the time, that's providing strain. If you look at the physical security part of it, 4K camera feeds, that's much more bandwidth intensive, and we're starting to push the upstream significantly because those video streams are being loaded to the cloud, so they're available to the consumer anywhere that they're looking, anywhere that they're tapping into their network. They may not be at home to look at their cameras. They may be on the road somewhere. Of course, this is 2020. We've definitely seen the COVID-inspired traffic surge. Literally a year's worth of growth in that month of March when the lockdown started. USA and Brazil up 50%, Canada up 40%. Individual service providers really felt that shift overnight. I'm sure in your networks, you saw the same kind of change in behavior and folks scrambling to set up their homes to carry out work, school, and really the majority of activities and really start to leverage online services. Companies like Comcast report 33% increases in upstream traffic all in 1 month. So this becomes very impactful. And these new behaviors are sticking with us. Schools are not fully open. More and more children are going full digital e-learning. And our school buildings, they don't have a lot of students in them right now. Depending on what state you're in, everybody might be digital learning. And that just really multiplies the impacts. So in the home, we're at home together now. So it's not just a parent or two working from home, it's parents and kids. And whether you're in school or you're working, those activities are kind of similar. But the interesting thing about it is you're not always just working when you're at home. It's a different environment. So, ask yourself, do you stream while you're at home? Do you have the TV on? Are you watching Hulu or YouTube Live while you're working on your spreadsheets? Are there people in your home doing multiplayer gaming? Are your kids gaming between their breaks? But I can guarantee it's happening. So these things really multiply, and these impacts are felt across multiple services. It's not just the Zoom video call. It's things like streaming in the background. Maybe you're watching this presentation, or maybe you're watching something on Netflix. Are there folks gaming? So all of these things add up together, and this is really driving bandwidth. So we've been looking at traffic growth at Adtran for a number of years and really focusing on understanding when GPON starts to run out of capacity. This is a function of a couple of different metrics that we track, things like the busy hour load. In 2019, it was up to 3.5 megs per subscriber. And that's just the constant churn of traffic on average that's going on with consumer broadband for each of our subscribers. This number is built based on the Cisco Vina study. And then we have a lot of metrics that come in from our partner service providers that we apply to it. And we're pretty confident 3.5 megs for 2019 was a pretty good average. So you got to ask yourself, what's your annual growth rate? What's that compounding factor that you're working with? Most networks seeing somewhere between 35 and 45% annual growth. So if you're in that 30% category on a 1x32 network, you've got a little runway out to 2029 when GPON just isn't going to meet your needs, especially in the upload. You're going to get into that penalty box. You can't deliver those 1 gig services in the busy hour. Every network's a little bit different, so it definitely pays to look at what's a 50% compound annual growth rate look like. We definitely have customers that are in that boat that are seeing their consumers on an even faster trajectory. So when you're looking at that 55% compound annual growth rate, your upload, that 1.5 gigs that you have on GPON, that starts to show exhaust as early as 2025. So every service provider is a little bit different. I recommend that everyone has a tool to pull these numbers. If you need them, Adtran has them. We can talk to you about them. Understanding this number becomes key in handling the upgrade to next gen, to going to 10 gig, understanding when are my PON networks going to be challenged. And you do need to get granular about this. It's worth being able to observe traffic rate and congestion on individual PONs. We have solutions for that. I recommend you partake in them. So with all of this bandwidth demand coming at us, we definitely have solutions to meet it. That solution today is XGSPON. XGSPON has definitely grabbed the momentum for the 10 gig, next gen fiber to the prem solution. And there is a lot of additional value and utility that you can get out of an XGSPON network. It really pays to start comparing the capabilities of GPON with gigabit residential, a little bit of overhead for residential growth, to compare that to XGSPON. The 10 gigs that we can apply with XGSPON gets us a lot more support of gigabit services in the residential market. Then there's additional overhead for business services. There's also plenty of overhead where you can start to see future applications doing things like 5G backhaul, mobile broadband expansion, where you're expanding your offering beyond a gig. So the return on investment is pretty significant today for XGSPON. That cost delta between the two is coming down. As we look at individual projects, we're starting to see some very compelling economics, and that's really where XGSPON is getting its momentum. How quickly can we drive the cost of XGSPON to that, kind of something similar to GPON? We're starting to see that in projects today. If you look at the electronics cost, comparing the same project built in GPON and XGSPON, just the blinky light boxes, the OLTs and the ONTs, you're looking at about a net 20 to 30% difference. If you're building a greenfield, though, where you have your outside plant, you have your permitting, you have your labor, in reference to a complete project, that delta becomes 2 or 3%. So being able to jump on board and add 10 gig PON today is starting to make a lot of sense. Adtran has been working significantly across the last 3 years to optimize our 10 gig deployment options. And really today, that means using combo PON. And what combo PON is, as I mentioned here, it's an optimization of XGSPON. A traditional XGSPON overlay is going to get you XGSPON technology and GPON across the same physical architecture. We've been talking about this since 2017, but there are some areas where we can improve it. So with the traditional model, we add a coexistence module, which is a passive box that allows us to combine all of our wavelengths and apply them on the same ODN that we initially deployed. One of the inefficiencies here is we have to plug in a passive box in front of our splitter. We have to find rack space for that. We have to find mounting. We have to clean all the fiber connectors. But we also have to add a second discrete OLT. So essentially, you're running 2 disparate access networks in the traditional model. There's some flexibility here that might be attractive, but when it comes down to it, you're building a second discrete overlay network. So at Adtran, we set out to address that part of the problem, and our answer to that is combo PON. Combo PON simplifies XGSPON. It gives us a way to use a single OLT and a single PON port to deliver both GPON and XGSPON across that same physical network that we built for maybe BPON, and we can deliver it with a single OLT. That's a significant change because now we are instead of building a discrete network to do the overlay, we're simply upgrading what we already have. Combo PON gets us those two technologies in the same footprint. Doing this eliminates the coexistence module. We don't have to splice in, we don't have to connectorize in front of our splitter anymore. In the past, that seemed like, well, it's not a big deal, I'm just plugging a box in. And really you are in most cases with the coexistence modules. But you do take an optical hit, your light budget changes. With Combo PON, you remove that dB loss and you pick up expanded service area. So you get roughly 20% better reach when you're looking at deploying an overlay versus Combo PON. You have less cost, less space, less maintenance dealing with coexistence elements. We pull that coexistence element into the combo optic, so it becomes part of the entire network. It's not a discrete component with its own lifespan, with its own maintenance needs, with its own space requirements. Because of that, we can drive a lot of the cost out of deploying Combo PON. You get a capital savings. You're spending less on a single OLT than you are on two discrete units. You have an energy saving. Combo PON, putting both technologies in one OLT, gets you an energy savings when you compare it to running two discrete OLTs. And of course, space savings. Service providers have seen their central offices really cleaned up over the last few years. I don't think the point of adding XGSPON to a network is to double the used rack spaces in our central offices or points of presence. Combining them in one single footprint is a serious advantage. We have an energy savings, capital savings, and a significant space savings. At Adtran, the 10 gig combo access module looks just like this. It's very similar to what we do in GPON. It fills the same physical footprint, and it gives us that way to deliver simultaneously over 8 ports, both GPON, XGSPON, or if we want to, both simultaneously. This simplifies our migration. And the work we've done behind the scenes, we've built in this idea of what we call PON inheritance. So when we swap a GPON OLT with our new combo OLT, all the provisioning, all the work that we've done, bringing up those 32 customers that are on the PONs on this OLT, all of that provisioning is preserved. It's inherited by the new card. And then we have XGSPON capabilities at our fingertips. It's a very flexible module, delivering those cost savings and amplifying your return on investment. The key to this all is the combo optic. We use an SFP plus form factor, and the combo SFP pluses have all of the intelligence, all the wavelengths for both GPON and XGSPON in a single unit. I can use GPON optics, I can use XGSPON optics in this card, or I can use combo optics. Complete flexibility for PON deployment. With the combo optic, as we start to think about the edge, we're no longer faced with, if I need to add combo PON or XGSPON to my network, I either need to inject a coexistence element, or I need to do the fire drill exercise of upgrading 32 customers all at the same time. With Combo PON, you have both GPON and XGSPON available, and you can change out your OLTs to suit your customers' needs. When those upgrades come in, you just swap the ONT out at the edge after you've prepped your combo OLT. Now we're going to take a quick look at a video. My colleague Gaurav has a quick demonstration of our combo PON OLT in action.
Hey folks, my name is Gaurav Negi. I'm a sales solutions engineer here at Adtran, and today I'll be giving you a walkthrough of our TA5004 micro cabinet. So this is the micro cabinet that Dan was referring to. This is, as you can see, it's a fully self-contained weatherproof design. And so it has a TA5004 pre-installed, as well as powering and cooling options are built right in. So with this design, it allows you to either mount the cabinet on a telephone pole, as well as be able to mount it on an exterior outside wall. So taking a closer look at the inside of the micro cabinet, you'll see a 5004 pre-installed. Now with this particular bundle, we have an AC power module in slots 3 and 4. We have an 8-port OLT module in slot 2, and there's a debug module in slot 1. So today I'll be demonstrating two very common scenarios that a lot of service providers run into when they upgrade their networks from GPON to XGSPON. Let's get started. So the first scenario involves a service provider that might have active GPON deployments using our Octal GPON OLT card. And I'll show you exactly how easy it is to go from an Octal GPON card to an Octal Combo OLT card without having to do any type of reprovisioning. We call this feature PON inheritance. So for those of you who might not be familiar with the Combo OLT card, this card allows you to do 8 ports of XGSPON along with 8 ports of GPON. So as you can see, I have a 401 GPON ONT that's connected to PON interface 1 on the Octal GPON OLT card. Now this particular 401 is pre-provisioned for a data service for a subscriber with a 200 meg symmetric internet connection card.
So as you can see, this ONT is currently in service and up. Now this ONT also happens to be provisioned for a data-only service for a subscriber with a 200 meg up and down internet connection. Now, using a traffic generator, I can simulate bidirectional traffic flowing through this 401 ONT. And there you have it.
Okay, now let's go ahead and replace the GPON OLT card with the Combo OLT card. Now this process may take a few minutes depending on how many subscribers you currently have online in order for the configuration to fully restore. So now that we have the card plugged in, I wanted to emphasize the fact that we took the GPON OLT optic from the previous card and replaced it on this Combo card.
So now, as you can see, the 401 ONT is back online. I can also verify that all the GPON provisioning has been restored. And lastly, I can verify that bidirectional traffic is still passing through the 401 ONT. So what we saw here with this demo of the PON inheritance feature is that the TA5004's ability to automatically port the GPON provisioning to the combo card without requiring any kind of manual intervention, making these type of upgrades that much easier. So for a large-scale GPON deployment, this translates to a huge savings in time and ultimately cost.
So there we have it. The Combo OLT, Gaurav did a great job in that session, kind of showing how we do that initial transformation. And then the great thing about the card is it supports multiple transitions. So we can set the stage for 10 gig PON, but run the Combo OLT with our existing GPON optics. So you can just order, in the Adtran world, you can just order the new Combo OLT, reuse your existing optic. You can also redeploy that classic GPON only OLT to a different area if you need it. So you can start making the investment today, and then you can transform as your needs change, as that usage number, as your compound annual growth rate starts to ramp. So you might have a period of time where you need to deploy some combo ports on this OLT. And as Gaurav will show you in the next video, we can do that on a port by port basis. So we can run a combination, excuse me, getting a lot of that term in here, a combination of GPON and combo optics in the card. And then eventually, as our needs really ultimately change, we can get to an all XGSPON look. But we've been building logically over time, deploying and growing as we needed. And when we get to this all 10 gig future, we'll have paid down and we'll have been making an investment in 10 gig capable OLTs for a number of years. So I'm going to let Gaurav and show you another video and have Gaurav show you how this transformation can occur on a port by port basis.
So the next demo I'd like to show you is how XGSPON and GPON ONTs can exist on the same PON interface using one of our combo OLT optics. So firstly, we remove the GPON OLT optic. We then swap it out with one of these combo OLT optics. We then proceed to connecting the 621, which is our XGSPON 10 gig single port ONT. We plug that into the splitter. So notice all I really had to do there was replace the GPON OLT optic with a combo OLT optic, and now I have the ability to connect both XGS and GPON ONTs on the same PON. So this will come in very handy for service providers that want to offer higher bandwidth services to their power users or businesses, along with basic services.
Now going back to the TA5004's CLI, we can see that both the 401 ONT and the 621 ONT are currently up and in service. Now notice that even though both ONTs are connected to the same physical port on the OLT card, they reference different logical ports in the CLI. Notice that the 401 references port 1, whereas the 621 references port 9. And so GPON ports on this combo card are referenced ports 1 through 8, whereas XGS ports are referenced ports 9 through 16. Now going back to the traffic generator, we can check to see if we can still pass 200 meg traffic through the 401 ONT and now 1 gig of traffic through the 621 concurrently. And there you have it. So this demonstrates the ability to service both GPON and XGS subscribers on the same combo OLT card, essentially giving you 8 GPON ports and 8 XGS ports on a single card.
You can now see that we can just do these transitions and migrations very efficiently and step through this growth rate into 10 gig capable PON. The other things that we need to think about for 10 gig PON, what other areas of the network are affected? ONTs. Today, we are launching for the premise our XGSPON ONTs, our SDX 620 line. This is a collection of specific SKUs that gives you economics and the ports you need to deliver services inside the home and leverage XGSPON. As we get into 2021, Adtran's going to be dropping Wi-Fi 6. This becomes essential as we're delivering multi-gigabit speeds into the home. Wi-Fi 6 is going to be key to distributing that. As we're ramping up our capabilities on the network side of the equation, we need to be thinking about what's going on inside the home. And Adtran has partnered with Plume to build that much better customer experience around Wi-Fi. So not only do service providers have excellent remote management and analytics tools, the consumer themselves has a great interface for managing their Wi-Fi network right on their mobile device. And we offer an extended consumer feature set here. So this is premium Wi-Fi, not only in the physical layer sense, but by adding and amplifying that customer experience. And our customers who are deploying our powered by Plume solution, they're just getting great reviews from their consumers. The other area that we need to think about is how do we feed our network? If we've got solutions for the home, for the access network, we need to build better uplinks. And we've done that with our TA5000. We've added 100 gig interfaces. So we're looking to the future, looking for that compound annual growth rate and preparing for it so we can build significantly larger uplinks into our TA5000 chassis today. Making this upgrade is key to enabling XGSPON services over the long term. Service provider networks have been built out, stretched into all different shapes and forms, using, in a lot of cases, 10 gig transport. We've got to focus in on that and figure out ways to amplify what we do in our transport networks. And at Adtran, we've been working on that for the last few years. The concept of link aggregated ERPS rings give us pathways to 40 gig networks that are very efficient and very affordable. So at Adtran, our solutions are architected for change. When you compare what we've built to other vendors, Adtran has built not for the specific technology era, but for the lifespan of an access network. So oftentimes vendors will build a system for a specific era. A TDM era had system 1, the DSL era had system 2, the GPON era had system 3, and now the 10 gig PON has system 4. At Adtran, we've worked very hard to future-proof our platform to make sure that we can address all of the iterations that happen in service provider networks over time. We really feel our TA5000 offering is a platform for the future. We're market proven. We're feeding over 1,000 gigabit communities, over 60,000 subs in these areas, 7 different optical technologies that you can deploy out of a single footprint. And across the globe, we've deployed over 60,000 individual nodes with this product platform. If you have more interest in what Adtran's doing in 10 gig, please visit adtran.com/10gig. You'll find multiple different resources there, case studies, cut sheets, product information, and a whole lot more. So thank you for listening today. I really appreciate the opportunity to speak to you, and I hope you have a wonderful rest of 2020.